Myself, Nazira Sultana, e-content developer, LMS team, welcome all the students and viewers. Today's session is for the course Switchgear and Protection of 5th semester Electrical and Electronics Diploma Engineering. Today's topic SF6 circuit breaker is from Unit 2 Fuse and Circuit Breaker. Before commencing today's session, let us try to have a recap about the previous sessions what you have studied. The topics which you have studied are circuit breaker, working of circuit breaker by trip circuit mechanism, classification of circuit breakers, and in classification of circuit breakers you would have studied different types of circuit breakers such as plain break oil circuit breaker, axial blast air circuit breaker, cross blast air circuit breaker. Today's topic SF6 circuit breaker is a type of circuit breaker. So hence we'll try to see and recapitulate what is a circuit breaker. A circuit breaker is an equipment which can open or close a circuit under all conditions. So, what does this mean? That is, circuit breaker is nothing but just like a switch. It can open or close the circuit but under all conditions. So, let us try to see what are those conditions. So, it can open and close the circuit in all conditions such as no load, full load and fault conditions. And it is designed in such a way to operate that it can be operated manually or automatically under normal condition. But when the fault occurs, it operates automatically. There is no manual operation. So this is the definition of a circuit breaker. Once again, we'll try to see it. A circuit breaker is an equipment which can open or close a circuit under all conditions such as no load, full load and fault conditions. It is designed in such a way to operate manually under normal condition or automatically under fault condition. Let us try to see further about its operating principle. So a circuit breaker has two important parts. One is called as a fixed contact, other one is called as a moving contact. Sometimes it is even called as electrodes. So how these act when the circuit breaker is in operation, we'll try to see. So when the system is healthy, when the circuit is healthy, when there is no fault in the circuit, the condition is called as normal operating condition. So in normal operating condition, these two contacts will be in closed position. That means there is no gap in between them. They are in contact with each other. They will not open. They will be always in closed position when the circuit is in normal operation. So when they will open, they'll open only if the fault occurs. That is what we say. Under normal operating condition, these contacts remain closed and will not open automatically until and unless the system becomes faulty. So this is the condition of the circuit breaker contacts when the circuit is in normal operation. Now let us try to see what will happen to them when the fault occurs. So when a fault occurs on any part of the system, what will happen? The trip coil of the circuit breaker gets energized and the moving contacts are pulled apart by some mechanism, thus opening the circuit. We'll try to understand this. So as soon as the fault occurs, the current will rise to a very high value, right? So there is a faulty condition in the circuit. Now when this condition happens, a trip coil is energized. So how does this trip coil energizes? Circuit breaker is just an interrupting device. It cannot sense the fault. So you will be having a relay along with this circuit breaker. The relay will sense the fault. It will close its contact and generate a trip signal and gives the signal to the trip coil. So the trip coil gets energized and it will operate the moving contact of the circuit breaker. So what it does, as soon as the fault occurs, it will try to move the moving contact away from the fixed contact. When it is doing so, what will happen? The moving contact will move away from the fixed contact. So in between there is a gap. In the gap you can see arc. So this arc will be there because of the fault. The current in this is there and it will be of a higher value. So if the arc is going to be present for a longer time, then you cannot interrupt the fault current, because the arc will produce lot of amount of heat. So if you have to control the current, high fault current, your first thing is you have to put down the arc, or you have to extinguish the arc. Once you extinguish the arc, then your current interruption can take place and the heat generation can be in a controlled way. If you don't do this, what will happen? There will be a damage because of high amount of heat. The heat can rise to a dangerous value. It can spoil the breaker itself, and you will not be able to interrupt the current. The fault current becomes more and more, and it can spread to the whole power system. So as soon as the contacts open and the arc comes, we have to use some medium to extinguish this arc. So when we looked at the types of the circuit breakers, you saw oil circuit breaker, then your air circuit breakers, and today you are going to understand about SF6 circuit breakers. So all these are the medium of extinction what we are going to use in the circuit breaker. So we have to use some medium and we have to see that the arc is to be extinguished. If as at the earliest it is extinguished, the damage caused to the circuit breaker and the other associated circuit will be very less. So circuit breaker will does the work of current interruption. How it will do? As soon as separates the contact, what will happen? The circuit will become like an open circuit. You will be having a healthy part and you will be having a faulty part. So this is the brief introduction about your circuit breakers. Now let us try to understand today's session. So in today's session, we are going to understand about SF6 circuit breaker. Then we are going to understand about its construction and working. Then merits and demerits. Then application. Now let us try to understand what is this SF6 gas, because it is the medium of extinction what we are using in the circuit breaker. So we'll try to understand first what is this SF6. So SF6 is nothing but it is a sulfur hexafluoride gas. So what is its nature? It is an inert, stable, heavy, electronegative gas having good dielectric strength and arc extinguishing properties. Because of this property, it is being used in the SF6 circuit breaker. I will try to understand each one. Inert. What do you mean by inert? Inert gas is nothing but a gas that doesn't undergo any chemical reaction under a given set of conditions. Stable. Stable means it doesn't react with any other gas or metal. Heavy. Heavy means its density is more. Sandrata jasti irutte. Electronegative. So once the sulfur hexafluoride gas is able to attract the mobile electrons colliding on the molecule, it absorbs those electrons and becomes into ions. These ions will not conduct your current. That is why it is called as an electronegative gas. And along with all these properties, it is having good dielectric strength and arc extinguishing properties. So because of these reasons, SF6 gas is highly recommended to be used in your circuit breakers. Next point about your SF6 gas is its dielectric strength increases with the pressure. So at normal pressure, whatever the value of dielectric strength is there, when its pressure is increased, the dielectric strength value will become more and more. So that is a advantage for us. If you increase the pressure and use the gas, then the dielectric strength will be more. The arc cannot stay there for a longer time and the arc can be quenched at a faster rate. And in turn, the damage caused will be less for the power system. Coming to its physical properties. SF6 gas is colorless, odorless, non-toxic, inflammable gas. So what does this mean? We'll try to understand. SF6 gas is colorless. That means it doesn't have any color. Odorless. It doesn't have any smell. Non-toxic. It is not poisonous. Non-inflammable. It will not catch fire. Next, the important property just now what we discussed is it has got a high dielectric strength. So when compared to air, we are going to understand, because air itself is a good dielectric medium. So this SF6 gas is having a dielectric strength more than air. How much it is? 2.35 times more than that of the air. It is having its dielectric strength. So these are the important points what you have to remember regarding your SF6 gas, because it is having all these properties. That is the reason why we are using as a arc extinguishing medium in the circuit breaker. So with this brief introduction about SF6 gas, we will try to see the SF6 circuit breaker. So the image what you can see here is a typical SF6 circuit breaker. It is of the rating 115 kV, 1200 amps. It is installed at a hydroelectric generating station. This is how a SF6 gas circuit breaker looks. Now coming to the classifications of SF6 circuit breakers. We have got two classifications. First one is puffer type SF6 circuit breaker. Second one is called as non-puffer type SF6 circuit breaker. So today what we are going to study is puffer type SF6 circuit breaker. Let us try to take up that. Puffer type SF6 gas circuit breaker. This is how your puffer type SF6 circuit breaker looks, and the important parts have been labeled here. We'll try to analyze them. When you look at the figure, this is figure A and this is figure B. So in both the figures, when you observe first, this is called as a fixed contact and this is called as a moving contact. You can see them in both the figures. But when you look at the first figure, see they are in closed position. There is no gap in between them. So this is before the fault has occurred. That means when the circuit is in normal condition, your contacts are in this position. They are like this. They are closed. When the fault occurs, this moving contact is pulled apart like this. So when it is pulled, a gap is created and you can see an arc. Right? We'll try to see the parts first. Right? So the first part here what you can see is called as a movable cylinder. That means you can move it. Movable cylinder. It is fixed on a movable contact. So number one is a movable cylinder. Number two is a moving contact. And third one is a fixed contact. And these two things what you can see is nothing but a insulating nozzle. It is a small opening which was wide here. It is reduced to a small opening. So it is an insulating nozzle. Then fifth one is your fixed piston. That means this contact is moving, whereas this piston is fixed on this moving contact. This cannot move. Only the moving contact can move. When it moves, along with it, it will move here and there. Right? So this is a fixed piston which is placed on a moving contact. When you look at the figure A and figure B and compare the gas, these dotted lines what we have marked indicates the SF6 gas. This is the condition of the gas before the fault has occurred. This is the condition of the gas when during the fault has occurred. When you look here, the gas is free and the cavity of the cylinder is large here. Can you see the space? It is large. This area you call it as cavity. This clearly tells us that gas is not compressed. It is free to move. Whereas when you look at this cavity, the cavity is compressed by this fixed piston and the moving contact. So once it is compressed, the space has become less, but the quantity of SF6 gas is same. So what happens? It gets compressed. Once it gets compressed, its pressure increases. So figure A shows the condition of the gas in a non-compressed state. Figure B shows the condition of a gas in a compressed state. and eighth one, this dark line, thick line what is marked, it is indicating the arc. So these are the important parts of a buffer type circuit breaker. Now let us try to see the construction. Whatever we have understood, we'll try to summarize that. So construction, single pressure buffer type SF6 circuit breakers are sealed units filled with SF6 gas at a pressure of 5 kg per centimeter square. So just now what we saw, it was a buffer type SF6 circuit breaker inside which we have filled SF6 gas. When we fill the SF6 gas, it is at a pressure of 5 kg per centimeter square. And the container in which we fill the whole assembly of the buffer type SF6 circuit breaker should be a sealed unit. There should not be any gap. If there is any gap, then there are chances of SF6 gas leaking. And once the SF6 gas leaks and comes out, then it causes lot of damages and failures, which we will see in the disadvantages later. So hence always we use completely sealed units for the construction of SF6 circuit breakers. Just now we saw the parts which are present in a SF6 circuit breaker. We'll try to summarize them. The SF6 gas circuit breaker consists of movable cylinder, fixed contact, moving contact, insulating nozzle, fixed piston, which are shown in the figure. Now let us try and understand how this buffer type SF6 circuit breakers work. So during normal conditions, I showed you in the sketch, the contacts are in closed position and the gas in the cylinder is not compressed. So they carry the normal current and the operation of the circuit will take place normally. There is absolutely no change in its working. So contacts are closed, they carry the normal current and the gas inside the cylinder. Which gas? SF6 gas inside the cylinder is not compressed. But what happens to this when the fault occur? So when the fault occur, so how will we come to know fault has occurred? The relay will tell the circuit breaker that fault has occurred. How it will tell? By generating a trip signal. So once the circuit breaker moving mechanism receives this trip signal, the trip coil of that circuit breaker energizes, the mechanism energizes and the contacts are pulled apart. When the contacts are pulled apart, depending upon the intensity of the fault, the arc, a smaller arc is struck or a huge arc is struck. So an arc comes into picture. Now because your moving contact which is placed on a moving cylinder is moving, there is a relative motion between these two. Now because of this relative motion, what will happen? The gas gets compressed. Once the gas gets compressed, what will happen? Same quantity of gas but the space is becoming less. What will happen? Its pressure increases. As soon as the pressure of the SF6 gas increases, it is released through the nozzle. So the higher pressure SF6 gas is coming out of the nozzle. So it will try to blow on the arc. How it is blowing? It is pushed or puffed on the arc axially along the arc. Along the arc it is been blown. As soon as this SF6 gas is blown on the arc axially, the gas removes the heat from the arc by axial convection and radial dissipation. So we'll try to understand what is this. So convection you would have studied in your lower classes. It is a process by which your heat is transferred from a body. And dissipation means cooling effect. The reducing of temperature is called as dissipation. Because these two actions take place, the heat from the SF6 gas which is burnt near the contacts is taken away. Once the heat is taken away, what will happen? It is easy for us to interrupt the fault current. So because the heat is taken away, what will happen? The diameter of the arc, right, the thickness of the arc will become small. By the time the natural current reaches the arc would have become so small that it is very easy for us to extinguish. How it will get extinguished? By the time SF6 gas will build up its dielectric strength. Why it will build up its dielectric strength? Because SF6 gas is a electronegative gas. That is why at a very faster rate it will build up its dielectric strength, and the arc cannot be there for a longer time. So in a very small duration of time, the SF6 gas will build back its dielectric strength which was lost due to the arc, right? Because of this reason, the arc cannot stay there and the arc gets extinguished. Once the arc gets extinguished, very easily your current gets interrupted and your circuit breaker is safe. This is how your SF6 gas circuit breaker interrupts the fault. Now, let us try to understand the merits of SF6 circuit breaker. The first merit is it has superior arc quenching property. Hence, they have very short arcing time. Just now when I was explaining the working of a SF6 circuit breaker, I told you that because they have got higher dielectric strength and SF6 gas is a electronegative gas, the arc extinction is at a faster rate. That is why they have got superior arc quenching property. Once they have a superior arc quenching property, then arc will not stay there for a longer time. So the arcing time will become very small when compared to your oil circuit breakers or air circuit breakers. SF6 circuit breakers have got very small arcing time. So once they have a shorter arcing time, it is an advantage. What is its advantage? You can interrupt much larger current. That is the second merit. So for the same rating of circuit breaker compared to your oil or your air circuit breaker, SF6 circuit breakers can interrupt much larger current because of this reason. And the next merit is noiseless operation. When you compare to a oil circuit breaker or an air circuit breaker, when the interruption takes place, for example, in an air circuit breaker, the air is blasted on the arc. So when this happens, there is a huge amount of sound. Here, such thing is not there. So it gives us a noiseless operation. That is the next advantage. There is no moisture problem. When we were understanding construction, we understood that the circuit breaker, SF6 circuit breakers have got sealed units. So once they are sealed, so outside moisture cannot enter inside the SF6 circuit breaker. So the moisture problem is not there. It is not present. No risk of fire. When I was discussing the properties of SF6 circuit breaker, I told you it is non-inflammable. That means it cannot catch fire. That is why you don't have risk of fire. Further merits are no carbon deposits. So what are these? We'll try to understand. When compared to a oil circuit breaker, there are more carbon deposit. So when the fault occurs, there also the contacts will separate, arc will come. So the medium between the contacts is what? There it is oil, here it is SF6 gas. So in an oil circuit breaker, the oil which is around the contacts will burn because of the heat of the arc. It decomposes and it tries to form the carbon deposits on the contacts. So after your fault is cleared, when you close the contacts, because of this carbon deposits, the contacts, moving contact and the fixed contact will not make a perfect closure. There might be small gap. So once there is a small gap, the circuit breaker will understand as though there is a fault. When the fault is there, only the moving contact and your fixed contact will separate. When the system is healthy, always they will be in close contact, they will be close, touching each other. Now because of carbon deposit in between the contacts, they cannot touch each other. The deposits are making a hindrance for them to touch each other. So this carbon deposit will lead to undue or unwanted tripping operations regularly on the circuit breaker. They might bring down the life of the circuit breaker. But such problem is not faced in SF6 circuit breakers because here no burning or no release of carbon takes place. So no carbon deposits are there. That is an advantage what we have got. Next one is SF6 breakers are totally enclosed and sealed from atmosphere. So they can be used in dangerous places such as explosion places, in your coal mines, because we blast the coal mines and we excavate the coal. When you are doing that, if you use any other circuit breaker, that might lead to a bigger damage, whereas SF6 circuit breakers will not cause any such problem. So they are used in such places. These are the merits of your SF6 gas circuit breaker, and the last merit is they have low maintenance cost, light foundation requirements, and minimum auxiliary equipments. So maintenance cost is less. Why? Just now above we have told no carbon deposits. Once there are no carbon deposits, the wear and tear out on the contacts is less, right? Once the wear and tear out of the contacts is less, the life of the circuit breaker is more. So minimum maintenance is required. You don't require any huge maintenance when compared to your oil circuit breakers or air circuit breakers, and they require light foundation when they are being installed. And the other supportive equipments what we use, that is auxiliary equipments required, are very less when compared to other types of circuit breakers. So these are the important merits of SF6 circuit breakers. Now let us move ahead and try to understand what are the demerits of SF6 circuit breaker. So SF6 gas is suffocating to some extent. We'll try to understand what is this. So I told you SF6 gas is filled in sealed units. Suppose by any chance if there is a small leakage of SF6 gas, now what will happen? SF6 gas will leak out and come and try to mix us in the atmospheric air. But because it is a heavy gas, it cannot get mixed up in the air. It will settle down in the atmosphere like that. So the people who are working in that area, when they take in or when they breathe the SF6 gas along with the air, there might be a breathing difficulty. So suffocation will be there. That is the problem caused by SF6 gas. Second one is the entrance of moisture. Suppose by any chance the moisture enter into SF6 gas breaker, then it is very dangerous and harmful for the breaker. It can cause several failures. In turn, it causes many failures and total breakdown of power system can take place. Then further, we have the internal parts need cleaning during periodic maintenance under clean and dry environment. So when you take up the maintenance program of the SF6 circuit breaker, you should see that you cannot just take up anywhere. The place where you are taking up the maintenance should be clean and dry. Why? Because you should not allow the moisture to enter into the circuit breaker. That is the reason you have to take care of this point, that you have to maintain a clean and dry environment during periodic maintenance. Next demerit is the special facility requires for transportation and maintenance of quality of gas. So SF6 gas is manufactured in the manufacturing unit, then it is brought to the place where it is being used. That means transportation facility is required. When you are transporting also, you should see that no moisture enters and the SF6 gas doesn't leak. So special facility should be required and maintenance of the quality of the gas should be taken up. So all these things require a higher cost, right? It is actually a costly gas. So these are the demerits of SF6 circuit breakers. Now let us try to understand the applications of SF6 circuit breaker. Let us try to see the first one. The first application is power distribution and control. So it is used in power distribution and control systems. Next, it is used in line protection for power circuits. In the power circuit for line protection, we are using this SF6 gas circuit breaker as a protective device. They are used as a protective device along with the transformers. So third application is for the protection of transformers. Fourth application is along with the capacitor banks. And fifth one is along with your rectifier circuits. So in all these areas, we use SF6 circuit breakers. Now, with this, we come to the end of this session. I hope whatever topics we have covered today are clear, let us try to summarize whatever we have learned. So to start with, we started the session with a review of whatever the topics you have studied in the previous session. Then we took up circuit breaker in detail. We understood what is a circuit breaker and how does it operate. And based on that, further we moved to the today's topic, that is SF6 circuit breaker. So SF6 circuit breakers use SF6 gas. Hence we saw its physical properties, we saw its chemical properties, then we saw what are its benefits, like it has got a high dielectric strength, it can extinguish the arc at a higher rate. All these points we saw in the introduction to SF6 gas. Later we saw your different types of SF6 circuit breakers. We have got two types. One is puffer type SF6 circuit breaker, second one is non-puffer type SF6 circuit breaker. And today's study was restricted to puffer type SF6 circuit breaker. So in this we saw its construction, then working both under normal condition as well as under faulty condition. Later we saw the merits, then the demerits, and lastly we saw the application. I hope with this you have understood all the concepts what we have cleared in today's session. Let us try to assess ourselves by answering the MCQs. Let us take up the first multiple choice question. In puffer type SF6 circuit breaker, the moving cylinder is coupled to dash contact, fixed contact, movable contact, stationary contact, none. So when we saw the construction, we saw that movable cylinder is fixed to movable contact. Your answers should be solution B. The answer is option B. So this is the answer for the first MCQ. Let us try to see the second one. The presence of SF6 gas when it is filled in the circuit breaker is your option B, 5 kg per centimeter square. It is the value of the pressure of the SF6 gas when it is filled in the breaker. Coming to the third one. In puffer type SF6 circuit breaker, the compressed gas is released through dash while extinction of arc. So whether it is through outlet, whether it is through inlet, whether it is through your nozzle or through your opening. So it is released through your nozzle. So answer is C, nozzle. Coming to fourth one. In puffer type SF6 circuit breaker, at current dash, arc diameter becomes too small and arc gets extinguished. Option A, unity. Option B, 0. Option C, density. Option D, none. So we know that when the natural current when it is coming near to the natural current 0, the arc gets extinguished. So your answer is B, 0. Coming to the fifth one, SF6 gas is option A, non-inflammable, option B, inflammable, option C, neither A nor B, option D, none. So we know that SF6 gas is a non-inflammable. That means it doesn't catch fire. That is why you don't have any risk of fire with SF6 circuit breakers. So your answer is option A. Coming to sixth one, SF6 circuit breakers are dash in operation: silent, noisy, heavy, and none. I told you SF6 circuit breakers doesn't produce any sound because there is no blasting of gas or any such thing which will take place when compared to in your air circuit breakers. So hence they operate silently. So answer is option A, silent in operation. Coming to your next MCQ, seventh one. SF6 circuit breakers are dash in size: big, massive, small, and none. So answer is option C, small. They are small in size for the same rating when you compare with the oil circuit breaker or a air circuit breaker. Coming to next one. SF6 circuit breakers are chemically option A, reactive, unstable, stable, none. So they are stable because SF6 gas is a stable gas. So your answer is option C, stable. Coming to next one. SF6 circuit breaker requires dash maintenance, maximum, minimum, no or high. So answer is minimum. They require minimum maintenance because there are no carbon deposit and no burning of any medium. That is the reason they require minimum maintenance. Coming to 10th one, SF6 gas is having the following physical properties. The first one, colorless, second one odorless, third one non-toxic, fourth one has all the above properties. So when I was explaining you regarding the physical properties of SF6 gas, there I told you it is a colorless, odorless, non-toxic, non-inflammable gas. So your option should be answer D, has all the above properties. So these are the few MCQs which are being designed on the topic which we have discussed today. I hope your concepts are clear with these MCQs. Let us try to see how are the descriptive questions coming from this topic. So, the usual descriptive questions asked in this topic are: list the merits of SF6 circuit breakers, and the second one is explain with a neat sketch working of puffer type SF6 circuit breakers. So the first question, when it is asked list the merits of SF6 circuit breakers, you are supposed to write the merits. Usually this question is asked for 5 marks, so you are expected to write at least 5 merits. We have discussed more than 5. Try to write the 5 merits. Each merit carries 1 marks. Coming to the second question, explain with a neat sketch working of puffer type SF6 circuit breaker. So this question usually comes in the examination for 10 marks. So you are supposed to write the sketch. In the sketch you have to write both figure A and figure B. In figure A you have to show the moving contact and the fixed contact in a closed position, and the gas should be in non-compressed state. Coming to figure B, you should show the separation of the moving contacts from the fixed contact. Arc should be present there and the gas is in the compressed state. These are the important points what you have to keep in mind when you are drawing your sketch. So both the sketches you have to draw. Then you have to write the working, then you have to write the construction and working. Both are expected from you to write. So each and every part, that is your sketch will carry marks, your construction will carry marks, and your working will also carry marks. This question usually appears in the examinations for 10 marks. So with these descriptive questions and MCQs, I hope you will be confident about the topic and you will be able to answer the questions in your examination. We'll try to see the references. These are the references for the topic what we had taken. With this, we come to the end of today's session. I thank each one who has given me this opportunity to deliver this session in a successful way. Thank you.